All right, today we got solving systems of linear equations with three variables. We haven't seen this a whole lot yet in your previous math classes, but this is when you're going to have three equations and then a common a, b, and c, or an x, y, and z point that they all have in common. And I guess this little picture here can kind of illustrate what that might look like if you were using three different planes. So like if you had three planes and then I guess intersect at a common point right there, that's kind of like what we're looking for. That's kind of a visual, I guess, of what you can be doing there. If there is no common intersection between the three planes like this right here, we would say there's no solution. And then if there are multiple points where I guess the three planes intersect at here, they intersect at a line right there. You saw that kind of in geometry there. You'd say there'd be an infinite number of solutions here. But we're focusing more on the algebra side of it. So the first couple here, they start out pretty easy. It looks kind of intimidating because they give you three equations. But the big idea is you want to figure out what variable you can actually solve for in a few steps. So I'm looking at these equations here. Notice you got two variables, one variable, and then two variables right there in your three equations. So find the equation that has only one variable, that 2a equals 12 right there. And then we're going to solve for whatever a is. We'll do that by dividing by 2. And you get a is equal to 6. And now that we have a equals to 6, now we can go and use that in our other two equations here. So we're going to plug a is equal to 6 into one of those two. Now obviously the first equation doesn't actually have a, so we're going to have to plug it into this second equation. Okay, so when we do that, we're going to have 3 times a, or 3 times 6, and then plus b. And then I'm going to use a capital B just so y'all can see the difference there. My 6's and b's look a lot alike there. And then, yeah, there we go. We get all that. And then I guess we have 18 plus b equals 13. And then after that, subtract 18. And that is negative 5 right there. Okay, so now we have a and b right there. And now we have enough information. If we go take that b value that we just found and plug that into our first original equation, then we can go find your final answer for your c, and then you have all three of your variables. So we're going to go 2 times b, which was negative 5, and then minus the c value, and then equals negative 13. I believe that's negative 10. Whoops, I guess I need to write it like this. Negative 10 minus c equals negative 13. And then we're going to add 10 to both sides. So that's negative c equals negative 3 right there. And then divide both sides by negative 1, or flip your signs around, whatever you want to call it, and you get c is equal to positive 3. So as far as writing as ordered pairs, you could if you want, but most of the times it's going to be all right to just list them all out like this right here. So those are your three different pieces of your one solution right there. And that's it there. So we're going to take a look here, I guess, at example B right here. Same idea. You want to figure out which of these you could solve for right here. What equation has only one variable here? So this has got 2, this has got 3, and this has only got 1 right here. So we'll solve that one first. Most of you guys could probably solve that without even writing it out. We'll go ahead and do that here for your notes. So that gets us b equals negative 1. Okay, and then after that, we need to figure out if I plug in b equals negative 1, there's obviously two places you could plug that. If you plug it into this second equation here, you're going to have something for that 4b, but you're still going to have two variables, which you're not going to really be able to do much with that. So we're going to plug it into that first equation right there first. So we'll go negative b, or negative 1 for your b, and then plus c, and then equals 4. And since we don't have anything really outside the parentheses, you can just write that as negative 1. And then we're going to add 1 to both sides. And you get c is equal to 5. And then after you are done with that, we're going to take all of those values that we just found, c and b, and we're going to plug them into that third equation. So we don't know what a is yet, but we do know the b and the c. 4 times negative 1, and then minus c, or minus 5, equals negative 3. And then we're going to get that a by itself here. So that'll be 2a. That'll be minus 4 minus 5 equals negative 3. Before we start doing things left and right, we need to combine our like terms. So that's negative 9 right there. And then that's 2a. I guess we need to add 9 to both sides. So that's 2a equals 6. And then divide by 2, and that's a equals 3. And you have your 3 pieces to your solutions there. Those aren't too bad there. I think you'll have a few of those on your homework. Now, where they get a little bit tricky and kind of long sometimes is when you have 3 equations with 3 variables. This is where we're going to spend the majority of our time here solving these here. So the whole idea is you're going to take 2 equations. At the same time, you're going to cancel out some type of variable with those. It doesn't matter which variable you cancel out. But you're going to choose a variable to cancel out, and then you're going to choose 2 other equations, and then you're going to have to cancel out that same exact variable. All right, so we're going to write that out here for our steps here. So for step 1 here, say choose 2 equations. I'm going to abbreviate here a little bit, and then I want you to cancel out a variable. For step 2, you're going to choose 2 different equations. Or let's say choose a different pair, I guess. Because you can use one of the same equations, you just can't use both of the same. So choose a different pair of equations. And here's a really important thing right here. We'll highlight this or circle whatever you want to do here. We're going to cancel out the same variable. That's the only way that's going to get this to work. As far as the method I'm showing you, that's the only way. So it needs to be the same variable. Make sure you circle that or highlight that or something. Okay, so then you're going to have 2 result equations after that. So basically you're going to use elimination, and then from the first 2 equations, you're going to come down to 1 equation. And then your different pair of equations, you're going to get that down to a different equation, and then you're going to take the 2 result equations and then you're going to use substitution or elimination. Usually elimination is going to be the best. So take your 2 result equations, use substitution or elimination to solve. Then after that, you're going to have your 1 variable, and then you're going to just take your 1 variable and then plug it back into your equations. And then take, I guess, solution and find other, I guess, pieces or the other solutions. Okay. So it's kind of a big list right there. Like I was saying, big thing that we need to look out for is canceling out the same variable. So actually, I kind of think about step 1 and step 2 at the same exact time. I look at all of these equations, and if I were to take 2 of them, what would be the easiest variable to cancel out? So I'm looking here, and I see all these y's right here. They all have coefficients of 1 or negative 1, positive 1 or negative 1 right there. So I think y is going to be the easiest variable to cancel out with all of them, but we only do 2 at a time. So like, for example, if I take these first 2 equations right there and try and cancel out the y's right there, the y's would cancel out real easy. I'd have leftover x and z. And then what you're going to do after that is take a different pair. You can do the first and the third, but actually in this case, I think it's going to be best to do the second and the third. And we can cancel out the y's with elimination as well. So then you're going to have your 2 equations, your 2 result equations right there. So we're going to do that. And I guess I'll color code it here. So if we take those 2 equations, we might sometimes need to modify them, but here in this case it does not look like we need to. So equals negative 1 x plus y plus 3z equals negative 3. Okay, so I'm going to use elimination here to eliminate your y's right here. So we're going to add your two equations. And that's 2x's. The y's will cancel out. And then you're going to have 4z. And then equals negative 4 right there. Okay, so that's one of the result equations right there. So I'm going to leave that there for a second. Next, I'm going to take a different pair of equations. This is part 2. And I got to cancel out that same variable. So I have to cancel out, since I canceled out y's right here, I'm going to have to cancel out the y's on the second pair of equations. So we'll go x plus y equals, or actually, plus 3z equals negative 3. And then 2x minus y plus 2z equals 0. Okay, and then with elimination, try to cancel out one of your variables. Luckily, we don't need to multiply by anything. The y's will cancel out when we add them right away. So you have 3x, and then I guess you'll have plus 5z, and then equals, I guess, negative 3. Okay, those are your two result equations. So now you're going to take both of these right here, and you're going to use elimination to either solve for x or solve for z. Okay. So, in my opinion, I mean, it'll keep the numbers a hair smaller if I cancel out my x's. So I'm going to do that. So we'll go 2x plus 4z equals negative 4. I'm going to keep them color-coded so you kind of see where everything comes from. 3x plus 5z equals negative 3. And obviously I can't multiply 2x by anything to make it cancel out with this 3x, and I can't multiply by the 4 by anything to make it look like 5. So we're going to have to multiply both equations. So I want to cancel out x in this case. It doesn't matter. You can cancel out y. So I need my x's to cancel them out. I need something that 2 and 3 divide into. That would be 6x. So I need one to look like 6x and then one look like negative 6x. So if I'm doing that first equation here, I'm going to multiply the entire first equation, or both sides, left and right sides, by 3 right there. And we're going to do distributive property there. That'll get us 6x plus, I guess, 12x, and then equals negative 12. Okay, second equation here need to look like negative 6x. So not only am I going to multiply by just 2, I'm going to multiply by negative 2. Just so I can get that negative 6x there. So it'll be negative 6x when you do it. Negative 2 times 5 will be negative 10z. I messed up one of my variables here. Okay, and then equals negative 2 times negative 3, it's positive 6 there. Okay, so now that we have our two result equations there, and they're lined up and ready to go, we can cancel out your x's here. So the 6x and the x, those will cancel out. The 12z and the negative 10z will add up to 2z. And then the negative 12 and 6 will be negative 6. And after that, we can divide both sides by 2. And then that'll get us z equals negative 3. Okay, so all of that to get negative 3 for your z value. Now that we have that, now we can go plug our z back into one of our result equations. If we do that there, we can find x and z, and then we're going to go and take the answers and plug that back into one of the original equations to find all x, y, and z. So a lot of steps here on these. I think, usually you're only going to get one per test or one per quiz. So I wouldn't stress out about having to do like 10 of these or anything, but yeah, a little bit involved here. So I'm going to take that z and I'm going to plug it back into, I guess we'll do this second result equation. And I'm going to do the one before I multiplied everything. So we're going to do this, 5z minus 3. Okay, so and just to show where it's coming from, I just rewrote it right there. Okay, so that'll be 3x minus 15 here equals negative 3. We need to add 15 to both sides. That's 3x equals 12. So then once you divide, that's x equals to positive 4. Okay, so now we're getting somewhere. I got x, I got z. Now we're going to go plug both of those into one of our original equations. Now we'll go ahead and plug back into this first original equation. Now let's take that, plug it in, take this z, plug it in. And I guess I'll do this here in green so we're not all over the place there. So x was 4. Well, here I'm going to write it out first. So it's good to have things real detailed in your notes just so you can kind of see where everything came from. Hopefully, follow again if you kind of forgot how to do something. So 4 minus y, we don't know what y is. And then z was negative 3. So minus 3 equals negative 1. And then combine your terms. You got 4 and negative 3. So that'll be positive 1. 1 minus y equals negative 1. We'll have to subtract 1. Be careful, those won't cancel out. It'll be negative y equals negative 2. So then when you divide both sides by negative 1, it'll be positive y equals positive 2. And those are your three answers if you want to write x equals 4, y equals 2, z equals negative 3. That would be your answer. So it takes a while to do one problem there on these. But I kind of went through, so some of you guys are going to, skip a couple steps and go through it faster. But that is it there. So we're going to try another one out and see what we got going on here. I think this is actually the last example here. So was the solution to the system use elimination? Okay, so once again, you're going to choose two different pairs. I like to think about what would be the easiest variable to cancel out before we even start. We can cancel out x's pretty easy. You can cancel out the y's pretty easy. You can actually cancel out the z's pretty good here. Now, if you're going to do the z's, I wouldn't choose the first two here because then you're going to have to multiply both equations and cancel out, the z. So, let's do this here just to kind of prove a point here. You can solve for different variables here. Let's do the first and the first and the last equations here. So, plus 3z equals 12, and then 2x, they'll let me write, plus 2y minus z equals 4. But actually, you know what? Now that I'm looking at these two equations, these y's are going to cancel out pretty easy. But so you could choose that there. We're still gonna roll with canceling out the z here, because we kind of said we were going to do that. Okay, so if I want to cancel out that z right there, you have 3z, and you need the other one to be negative 3z. So I'm going to need to multiply by actually 3. The z is already negative. So that'll get us 6x plus 6y actually, and then minus 3z, and then don't forget that last number there, equals 12. Okay, and then now whenever we combine our equations, we should get some stuff to cancel out. So that'll be that right there. When you combine up your equations, you're going to get 7x, and then plus 4y, and then the 3z's cancel out, and then I guess equals 24. That would be your first result equation there, and we'll color code that with red. Okay. So yes, I could have canceled out the y's, but remember we already decided we were going to cancel out the z's between everything, so we want to stick with that on this right here. So the z's, I need to choose a different pair, so I could do the second and the third. I could do the first and the second. I'm going to do the second and the third equation here. I'll do it in blue, just so y'all have it. So let's write that over here. 2x minus y, and then minus 2z. My 2's and z's kind of look as similar, so I put the little line through it. It's 5, and then 2x plus 2y minus z, minus 1z, I guess, is equal to 4. Let's see if I make this look a little bit more like 2. There we go. Okay, canceling out z. So one of them is already negative 2z, so the other one needs to be positive 2z. So let's take this second equation right here, and let's multiply that by, I guess, negative 2, because you want a negative times a negative z right there. You want it to become the positive z. So we're going to multiply by negative 2 to everything. Right, so that'll get us negative 4x. That'll get us minus 4y plus 2z, because of the negative times a negative, and then equals negative 8. Okay, so your x's don't necessarily cancel. Let's see here. That'd be negative 2x when you combine this. Your y's, you'll get negative 5y when you combine. The z's should cancel out. And then 5 and negative 8, that should be negative 3 when you combine them. And notice I didn't rewrite the equation here. I just kind of used those two right there. So some people are comfortable with that, or if you want to rewrite the same equation again, you can. So now we are ready to roll here. We got our two result equations. You have the negative 2x minus 5y equals negative 3. And then I guess over here we'll do it in red. I guess I kind of changed colors halfway through, but that's okay. 4y equals 24. Okay, so those are your two equations. Decide on a variable you want to cancel out. It's not really a benefit to choosing one or another. I guess I'm going to go with y's here. So think about a number that 4y and 5y go into, so that'd be 20y. So we need one to look like 20y and the other one to look like negative 20y. Okay, so first equation here, let's multiply. Oops. Let's multiply by, what do we got? So 4y right there, you need to multiply by 5. Okay, so that'll get us to 35x plus 20y. Getting some large numbers here, that's okay. And 5 times 24, I think that is 120. Okay, and then the next one here, we're going to multiply this entire equation, and we need it to be negative 20y, so we're going to multiply by 4. And let me check that. 5 times 24. Sorry about that. Okay, so 4 times that, that'll get us negative 8x, negative 20y, and then equals, I guess, negative 12 right there when we multiply. Okay. Then we're going to combine our answers here. So the y's are going to cancel out here. The x's, when you subtract them, 35 and negative 8x there. I think that's 27x right there. And then equals, I guess, 108. And hopefully that goes in there. Usually these are going to come out pretty clean. So if you get something pretty wild, probably doing it wrong. And, these are kind of good questions here to start. But then if you kind of like get stuck on it, maybe, take a break, come back to it in 5 minutes or something like that, work a couple of problems, and then start fresh. But it looks like we're coming out pretty clean. We got x is equal to 4. So that is good. So now we need to take x equals 4. We're going to plug it back into one of the new equations here. Let's see if I can cut that off there. One of the result equations right there. The second one looks a little bit easier, in my opinion. So we'll plug that in. 2 times 4, and then minus 5y equals negative 3. So that's negative 8. And we're going to add 8 to both sides. So that's negative 5y equals 5. And then divide by negative 5. That's y equals negative 1. Okay. And then after that, I guess we're going to plug all that back in. Y equals negative 1. Let's see, what's the color we hadn't used yet? This dark blue we have not used. And then we're going to take x and y and plug that back in. So as far as which one's the easiest, they're all kind of the same here, so I'm going to use that first equation. So we got x was 4, so that'd be 4 minus 2. Y was negative 1, so 2 times negative 1
and then plus 3z, and theoretically we can solve for z now, since we have all that. So that'll be 4 plus 2, and then plus 3z equals 12. So 4 plus 2, that should be 6 plus 3z. Subtract 6, that'll be 3z equals 6 actually, and then divide by 3. And that should get you z equals 2. And then you are done, believe it or not. So it's a lot, but if you write out all of your steps, you're going to be good. And also, this one's a little bit longer than the previous one because I had to multiply to cancel out like some of the equations here. So try to avoid multiplication. It might have even been better to, cancel out the y's instead on this one. So, but, there's not one approach to these here, but everyone should get the same answers at the end. So, anyways, that is it here for your lesson today. It's kind of, there's not a whole lot of variation other than that. So, just practice it, take it slow, and you should do okay on it.